So today we are going to talk about the rank of the matrix, rank and the row reduced form. Um, so in most of the examples that we have seen before in the tutorial is that the m cross, if we have an m cross n matrix, then the second row or the third row might be the combination of the first row, or the second row might be the same as the first row, so we'll get it as 0, or the third row might be the sum of the first row and second row. So there we will get the entire row, we will get it as 0. So the dimension of the matrix doesn't define the rank of the matrix, whereas the number of pivots will define the rank of the matrix. So that is what the point which is written here. So the rank of matrix A, the rank of matrix A is the number of pivots. For example, after reduction, after elimination process, we will get the matrix A into some form, and we see how many pivots are there, and then that will become the actual rank of the matrix. It doesn't depend on the linear systems. Now for example, we have three equations, that is 3x plus 2y plus z equal to something. Likewise, if we have such three equations, it doesn't mean that the rank of the matrix is 3, but the rank of the matrix depends purely on the number of pivots in the matrix. Now let us see an example here to understand rank of the matrix. So let us take the matrix A is equal to, that is 1 1 2 4, then 1 2 2 5, then 1 3 2 6. Okay, so this is our A matrix. Now let us go with the elimination, row elimination process. We know how do we eliminate the rows. So what we will do is that we will subtract the row 2, sorry, I will subtract the uh, row 1 from row 2, and also we will subtract the row 1 from row 3. So what do we get in such case? So first row will remain to be as it is, so we'll get 1 1 2 4, and then the second row will be, this will become 0, this will become 1, so this is 0, then we will get here this as 1, and third row we will get this as 0, this is 2, then we will get here 0, then we will get here this as 2. So now we will reduce the once again the last row here by again multiplying the 2 times the row 2 minus with row 3. Then what do we get here? The final equation is that, so row 1 remains to be as it is constant, so we will get here that is 1 1 2 4, and then here we get this remains to be constant here now, so 0 1 0 1, and the third row will going to be, this is 0 0 0 and 0. So now if you see from this, the third row has become completely 0. There are no elements in the third row. So now we can say that the rank of the matrix is equal to 2, that is R is equal to 2. But we'll go one step ahead by to get the, now this is in the kind of upper triangular form. This is an upper triangular form. Now you can see the two pivots, so the one pivot is here and the second pivot is this one. So now we will go for the reduce method. Reduce method, what does it say is that we have to remove even the values above and below the pivots. Now below the pivots anyway here it is 0, above the pivots there is a 1, so we'll go for a reduced form method. So if you go for a reduced form method, then we'll write this is equal to R. So then we can write this is equal to R. Then what do we do is that, so we will subtract the you can subtract or minus 1 times the row 2 plus row 1 is also fine, so both are same, so R1 minus R2. So what do we get here is that, so this 1, so this will become 0, so this will remain 2, and the last we will get here as 3. and the second row will remain to be same, so that is 0 1 0 1 0 0 0. Third row is entirely 0. So now this is the what we will get. So if we try to find the solution with the upper triangular matrix, let us hold for a while for this reduced matrix. Now let us find the special solution using this upper triangular matrix. Then what do we get? So this, using the upper triangular matrix, we can find the solution as, now if you see here that the row 3, now how many free columns or free variables we have? We have uh, two free columns, that is row 3 and the column 3 and column 4. So now the column 3 is nothing but the multiple of 2 of column 1, and column 4 is also it is obtained by combination of the column 1 and 2, that is the combination of the pivot columns. So now if we try to find the special solution for this case, so that we will write, that we have to write like this, in this form. So where we will write this as x1, which is 1 0 0 plus, then x2 we will write this as 1 1 0, then x3 plus x3 is equal to 2 0 0, and plus x4 we have, that is 4 1 0. So now here we'll make the x3 equal to 1 and x4 equal to, we'll make x4 is equal to 0. So then what happens in this, because for a free variables we can substitute either 0 or 1. So we'll make alternative 1 and 0. So first we'll make the one of the free variable as 1 and remaining all free variables as 0. So the number of special solutions also depends on the number of variables, free variables. So here we have two free variables, it means we'll get the two special solutions for this upper triangular matrix form. So now what is the value of x that we'll get? Now if we rewrite this equation, then we have here, that is x1 is 1 0 0 plus x2 is 1 1 0, and here we will get, this is equal to minus we will get 2 0 0. So it means in this case, to make this right hand side equal, so here the x1 should be equal to minus 2 and x2 should be equal to 0. So then the special matrix that we will get for this case, that is S1, I can write here, this is minus 2, that is minus 2 0, then 1 and 0. So this is one of the special solution for this. So now I'll going to erase this and rewrite the for second case. So second case, what we do is that we will make the x3 is equal to 0 and x4 is equal to 1. So let us make this as 0 and this as 1. Then our right hand side of this equation will be, now this will be, what we get here is that we'll have 4 1 0. So now to get this, what should be the value of our x1 and x2? So let's see. In the row reduced form. So here to get this value is minus 2, minus 3 and minus 1. So if you substitute x1 is equal to minus 3 and this with minus 1, we will get here minus 4, and here we will get this as minus 1. So my second special solution matrix for this case is equal to S2 is equal to, that is we have minus 3, then x1 x2 is minus 1, then 0 and 1. So these are the two special special solutions for the upper triangular matrix. So now here there are two special solutions for because we have two free variables. Now let us see the solution for this reduced form. So the number of solutions for the reduced form is only one. So that is because we'll consider that only it is the combination of pivot columns should provide the free columns. So that is the condition. So let me clear this section. So this section is not required now. So I'll remove this. Now if you come to the reduced form, so let me write here the statement. So what does it define is that so the rank of the matrix is 2 anyway. So this is given by the R is equal to 2, the rank of the matrix for upper triangular form. So as well as the for column also, for the reduced form also, the rank of the matrix is 2. Now for the R matrix, it is the combination of the pivot columns that produce the free column. So now if you see the combination of this, so combination of pivot columns that produce the free column. So that is the third column we will get from the first column, and the third column we will get here. So now the solution for this case is that, then we can write this as equal to, now that is x1, that is 1 0 0, and plus x2 is equal to 0 1 0. We will take the non-zero, we will eliminate in this reduced form. What we do is that we will eliminate this 0 row. So we will take only the rows which are non-zero. So we have, that is 1 0 in this case, plus then x2 is 0 1, and plus x3 is 2 0, and x4 is 3 1. So then if you look into this case, this R3 is not a combination of the pivot column. So we'll make this x3 is equal to 0. So then we have here, so x1, so then we'll make x4. x4 is a perfectly the combination of the two pivot columns. So for that case, if x1 is equal to, when we send this x4 column to the right side, then it will become minus 3 and minus 1. So this is equal to minus 3, and if x2 is equal to, minus 1, then we will get this the solution here. So the special solution for this case, there is only one special solution, that is now s is equal to minus 3, then minus 1 0 and 1. So this is a special solution for this case. Now if we talk about the matrix of rank 1 has only one pivot, so there is another form of writing. So let me save this page. Let's talk about the rank 1 matrix. So here, page 93. So let's talk about the take the new page and talk about the rank 1 matrix here. So rank 1 matrix has only one pivot. Now if we take an example here and illustrate, so we have A is equal to 1 2 3, then 3, 6, 9, 10, 20, 30. Then it's reduced row form. We can straight away, now if you look into this, the second row we can eliminate by multiplying 2 to row 1 and subtracting with row 2. Then what we get here is that I'll quickly write this. So 1, 3, we have 10, and here we'll get this as 0. So here also we'll get 0, and this also will get 0. So whereas this, if you multiply by 3, we will get this as 0, 0 and 0. So basically this is in a reduced, already in the reduced matrix form. So it means U and R here both are same. So now if you look into this matrix A, then the third column is the sum of the first, the third row is actually the sum of the first row and the second row. So here if we can state that, so now what is the rank of the matrix here? So rank of the matrix is equal to 1. So rank of the matrix is 1, which has only one pivot. So what is that one pivot we have? So this is the one pivot. So when the elimination produces zeros in the first column, it produces zeros in all the columns. This is a very important point. So here it has produced the zeros in the first column here, so it means it also produces zeros in all other columns, and every row is a multiple of pivot row. At the same time, every column is also a multiple of the pivot column. Now if you see, every row is a multiple of the pivot row. So if you multiply 2 to the first column, we will get the second, if you multiply 2 to the first row, we will get the second row. If you multiply 3 to the first row, we will get the third row. So likewise, if you look at the column also, if you multiply 3 to the first column, we will get the second column. If you multiply 10 to the first column, we will get the third column. So then in such case, we can write, so now let us write this. Now the column space of the rank 1 matrix is one dimension. So this is another point which we have to remember here. So now the U, the upper triangular matrix, it is just 1, 3 and 10. And then the vectors, if we write, so now what is the vector that we have? So we have 3 vectors here, that is this is the first column, second column and third column. If I write this in terms of transpose, so then I'll get this as vector 1, 3 and 10. Okay, so then the special rank we can write in this way, that is A is equal to U into V transpose. So then we can write this, the A is equal to column times row. So that can be defined as V in U into V transpose. So which is nothing but, here this is equal to that is 1, 3, 10, then 2, 6, 20, and 3, 9, 30, which is equal to, we can get back our matrix A from U and into V transpose, so that we can write this as, actually U is, my mistake. So U is, we have written this in terms of the vectors, so that is actually not universal matrix. So U is 1, 3, 10 and V is the transpose of U. So then if you write V into U into V transpose, then we will get here, this is 1, 3, 10 and here this is the transpose, so that we can write this as 1, 3, 10. So if we multiply these two matrices, we will get back our A matrix. So, and also now the special solutions for this case is that since there is only one pivot row and how many free variables we have, 2 free variables, that is x2 and x3. So then if we look into that case, we can straight away look into this case and we can say, so to get this 3 and so x3, this is x2 and this is x3. So if we make x3 is equal to 0, we'll have this x2, and if we send to the right side, we'll get minus 3. And then if we multiply the x1 with 3, we'll get the special matrix. So S1 we will get here as the one of the special matrix as minus 3, then 1, 0. And the second special matrix, if you look here, that the 10. So when we make x3 is equal to 1 and x2 is equal to 0, so then we can see here that is x2 is equal to, we'll get here minus 10, 0 and 1. So these are the two special matrix. So now from this we will come to one final conclusion, that a null space contains the combination of these special columns. So whatever these nulls we are considering this is equal to the right hand side is equal to 0. The vector on the right hand side is equal to 0, so it means we are defining it is in the null space. So the null space contains all combinations of S1 and S2. Then the null space is perpendicular to the row space. So here in terms of geometry, we'll define few things. So let me write here. So here row space is equal to line, whereas null space is equal to perpendicular plane. So row space will give us the line, just a line, single line, and the null space will give us the perpendicular plane. So now here for this solution, so null space is perpendicular to the row line. That is what it means. And the rank R is a dimension of, is also the dimension of the column space. So that is another point which we have to remember. So this is about the rank of the matrix. So next we'll talk about the pivot column.